Test. 1, 2, 3. Testing, testing. Good afternoon, everybody. This is a live extreme weather briefing. We have a lot to talk about today, especially the severe weather event that's ongoing in southern lower Michigan. I am using a new setup here. I got my armored Dell laptop that I often use, and I'm chasing down hurricanes or severe weather in here. Has an updated video card. Looks like it's moving a lot smoother as well. And here you can see Hurricane Larry moving very slowly off to the northwest. It is entraining quite a bit of dry air as well. That's causing it to weaken just a little bit. Maximum sustained winds are down to 115 miles an hour. The minimum central pressure by Hurricane Recon is up to 967 millibars. So it is gradually weakening a little bit. It does have a lot of dry air that's around it. It is moving off to the northwest around the western periphery of a Bermuda high. And it looks like it is going to be passing even further away from Bermuda now, which is very good news. Basically expecting no impacts there in Bermuda. But it also looks like it's going to miss Labrador a little bit off to the east as well as a transitioning tropical into an extratropical cyclone. But that is definitely good news that it is going to avoid Bermuda out there. But we do have this severe weather event that's ongoing right now in lower Michigan. And my uncle up in Traverse City had a shelf cloud come through, severe thunderstorm warning up there in Traverse City. Cadillac just had that severe storm move through. It is off to the south right now. You can see that little appendage that's sticking down. These storms are elevated supercell structures. So if you can see this one here, that's off to the west of Peacock, down south of Wellston out there as well. That's an elevated supercell structure. I know that it's elevated because I was just looking at the RAP meso-analysis, and there definitely is some convective inhibition out there, but the convective inhibition is gradually weakening as we're going through the day today across lower Michigan, and I'm going to show you what that looks like as well. You can see that there is a slight risk in place, and that includes a 2% tornado threat. That tornado threat's going to increase later on as we go through the afternoon hours. And there's also a severe thunderstorm warning back in the Milwaukee area, southeastern Wisconsin, Menominee Falls, sliding in to the Milwaukee area. Damaging straight line winds are expected with this storm here. Zooming in a little bit closer, you can see this line settling in toward the north side of Milwaukee. Damaging straight line winds the main threat, and that's because there still is quite a bit of convective inhibition with this storm. I'm just getting used to some of the new features on here now that I'm using a PC instead of a Mac. I got so used to using a Mac over the years that I am going to be moving just a little bit slow during this briefing, but I'll get better. Practice makes perfect. Here you can see, you can tell that these are elevated structures kind of strung out a little bit southwest to northeast. They're not quite rooted yet in that boundary layer. Then they'll be moving a little bit slower, turning off to the right. Houghton Lake, you have a severe thunderstorm warning. In effect, 60-mile-an-hour straight line winds. You do have a little bit of an elevated supercell structure. You can kind of see this little RFD structure there. A bit of a forward flank gust front structure there as well. Probably hinting at the fact that there is an elevated mesocyclone there, and can definitely enhance some of the damaging straight line winds, especially on the southern side of this with that RFD sliding off to the right. But there is that main core, damaging downdraft winds there. Maybe a little bit of hail, probably some nickels up there. 1-inch diameter hail is what the official warning statement says there as well. We can look a little bit closer on reflectivity, and you can see the hint at an elevated mesocyclone here on the southern edge of that warning. Probably even a tendency for some stronger winds associated with this RFD-like feature just to the east of Butterfield, basically on the southern edge of that severe thunderstorm warning. That's where I do expect the greatest threat of that severe weather. Basically because of that elevated mesocyclone enhancing some of those winds and those winds that are able to mix down to the surface. So Butterfield, even though you're not included directly in that severe thunderstorm warning, you probably should be there because I do expect there to be some damaging straight line winds there as well. Here is the target area. I do think that the threat of tornadoes is maximized across eastern lower, basically the thumb area of Michigan, maybe down into central lower Michigan, but that wind shear is going to eject over top Lake Huron over towards southern Ontario. But I do think that those storms are going to become more outflow dominant as they pass over Lake Huron. But those lake waters are relatively warm this time of year, so I do think that there is a chance of some water spouts, maybe some tornadoes, or at least those supercell structures to maintain surface-based characteristics even as they move over top Lake Michigan. But you can see that trough anchored over western Ontario there. It is an intensifying trough, and just like with hurricanes, how there's a big difference between a hurricane that's intensifying on approach to landfall and one that's weakening on approach. The intensifying hurricane has much more substantial impacts. In this case, with the upper level storm system intensifying on approach to the northern Great Lakes, that's going to help to excite a 40-knot low-level jet. And I do think that there is a potential of a tornado or two across central and eastern lower Michigan here. So let's pull up the models, some of the short-range models, and take a look, and at the surface maps. Some of the forecast models were showing a little bit of a drier, low-level environment across lower Michigan, so we'll take a look at that surface map as well and see how the forecast models have depicted the evolution of that surface-based instability, the moisture as well. We'll see if that's going to be a limiting factor for tornadoes later on today. So let's start off, first of all, with the mesoanalysis here, and we'll monitor the progression of that surface-based instability. There we go. And it does look like you're starting to get some surface-based instability here. Let me transition. There it is. Hopefully this is all working good. New equipment here, upgrading. Seems to be working pretty well so far. Definitely the video card is a major upgrade on this laptop. So here you can see the surface-based instability. This is as of 17Z, so updated just a little bit ago, and you can see that warm front cruising northward through central lower Michigan. And once that surface-based instability reaches those storms, then we're going to start to see a tornado threat begin to increase, and that is starting to happen there with the tail end of those supercell structures that have just made landfall from Lake Michigan. So that the blue shaded area, that's convective inhibition. The area that is void, that doesn't include that blue shaded area, has surface-based instability. So you can see that cape there, about 1,500 to 2,000 cape, lifting northward with that warm front, and that warm front is just about to meet that line of storms. But then the winds will veer a little bit. Notice how those surface winds shift to a west-southwesterly direction as that warm front lifts off to the north. But it does look like one of those supercells is going to dominate as it moves across northern lower Michigan there along that warm frontal zone and basically become a bit of a pseudo-surface low. Where off to the east of it, winds remain relatively backed, including that low-level jet in the thumb area. See that supercell storm? If it becomes surface-based, it should move a little bit deviant off to the right, could latch onto that warm front, and then move off to the east in association with that bigger shear. And then you get an expansion of that line off to the southwest. And the one thing that the wrap doesn't, well, it does seem to pick up on those initial storms there in the Milwaukee area. A lot of convective inhibition, though, southeastern Wisconsin into northern Illinois there. That should be able to keep those storms relatively elevated and more of a damaging wind threat. So now let's take a look at the real surface obs. Let me make sure that we are looking, and you can see those big southerlies. And boy, the 3-kilometer NAM definitely did a better job with the dew points, especially compared to the HRRR that had 50s dew points across lower Michigan by this time. You got low to mid 60s dew points streaming across the lower peninsula of Michigan there. Let me make sure that I'm showing the correct screen. Slide that off to the right a little bit so you can see lower Michigan surface obs. The dew point to bottom number shows you that moisture. And definitely even some low 60s dew points back into southeastern Wisconsin, northern Illinois. Not the 70 into low to mid 70s dew points that we had during those big tornado events and severe weather events across the Midwest that happened this year and northern Iowa, but it's not 50s as the HRRR was showing, and that's why I dislike the HRRR, because of its substantial dry bias. So let's take a look at the current HRRR here and see if it's actually updated the dew points a bit. And this computer definitely is working great. Thank you, Dell. Finally putting this thing to use. There, the initialization of the HRRR definitely has that convective line well initialized all the way down to just north of Milwaukee a bit. Let's see what the dew points are. See if the 16Z HRRR has it handled right. And you can see that it still has that dry bias. Even the 16Z HRRR has those dew points falling into the 50s down into southern lower, when they're actually still about 2 to 3 degrees warmer than that. Decent initialization, though, down into northern Illinois. Low to mid 60s dew points. You're not getting those 70s dew points out there, certainly. Let's take a look at the 3-kilometer NAM, see how it did dew point wise. Much better. In fact, even a little bit higher along that warm front, showing a little bit of pooling of those dew points, when the surface map really shows more of a 63, 64 type of a dew point. They're lifting off to the north. So here is that low-level jet. Pretty strong, relatively veered low-level jet. Definitely more unidirectional flow here, mainly speed shear being contributed. This is at 17Z, and so we can step forward. Let me make sure that I'm centered properly. Oh, not even close. So there you can see the low-level jet, 850 millibar winds. You've got 35, 40 knots, even 50 knots up there near the warm frontal zone out of the west-southwest by 18Z. And watch how this evolves, stepping forward to 20Z and intensifying low-level jet. And that's because we have a strengthening upper-level system leading to a low-level jet that strengthens with time. And you have that surface-based instability lifting up to this convective line. And for that reason, that's why I think that there is a decent tornado threat today. Some of the limiting factors are relatively dry with the low to mid 60s surface dew points, unidirectional low-level flow, with the main contribution to the storm relative felicity being from speed shear out there, and a relatively progressive system. This wind shear does eject off to the northeast towards southern Ontario at time. This is about 5 p.m. Eastern time out there. But man, look at that low-level jet just intensify. The surface winds do veer with time across central lower Michigan, back toward northern Indiana, and especially northern Illinois. And surface winds and that low-level jet veer, despite it intensifying above 50 knots down there. That's at the very least going to proliferate this squall line as it sags off to the southeast. But I do think that the most backed low-level jet, the most backed low-level winds are going to eject by this time across southern Ontario, over Lake Huron there, and those more backed surface winds underneath that slightly more backed low-level jet, right near the nose of that low-level jet, is going to be passing over Lake Huron towards southern Ontario. Likely a supercell storm to be ongoing there in central Lake Huron. Oh, man. There we go. Still getting used to this. Composite reflectivity on the HRRR. Look at the linear configuration. Possibly some of these storms on the northern edge of that squall line up there, out over Lake Huron. Could be some supercellular modes that eventually pass over that eastern shoreline of Lake Huron, which is at the Godrich area out there. Southern Ontario could have a tornado threat, but that accelerating low-level jet, big-time bulk shear, is going to maintain relatively vertical-oriented convection along the leading edge of that squall line. And this is a monster squall line by about 5 or 6 p.m., sliding south toward the Grand Rapids area, down towards Chicago as well. Maybe it could be some severe storms down in southeastern Kansas, northern Oklahoma, additionally out there. But quite unidirectional flow between 850 and 500. And look at the leading edge of this jet streak, forcing up this squall line across central lower Michigan there, mixing down these very strong mid-level winds down to the surface by that convection, damaging wind event, big-time wind bag event, sliding south toward Grand Rapids, central lower Michigan. Not quite the big-time wind down in Chicago, but you will have severe storms down there. A majority of the kinematics, as you can see, are ejecting across lower Michigan there. Let me make sure I still got the right view, and we do. Good. Still dominating here. So let's take a look at what kind of CAPE values we're going to get. We've already got 2,000 CAPE lifting up through lower Michigan. And definitely a majority of the surface-based instability is associated with those deeper dew points back across northern Missouri, southeastern Kansas, nosing up into northern Illinois. But still 1,500 to 2,000 CAPE across lower Michigan. Plenty of surface-based instability, slightly greater CAPEs in place across southern Ontario near the nose of that squall line, where you could have an even greater tornado threat over there. Let's look at some of these forecast soundings and photographs across Michigan. Look at this well-defined warm frontal zone with a 3-kilometer dam pooling that moisture along that warm front. Looking at the surface map, it doesn't look like we're quite pooling as much as this model is showing. I do think that tornado threat's going to be maximized relatively early in the convective cycle. If you get a 67 dew point pooling up there against the warm front, big-time low-level lapse rates, and big-time CAPE as well, thick CAPE up there, and that photograph is very favorable with a 40-knot southwesterly low-level jet. And early on in the period, in the vicinity of that warm frontal zone right now, more southerly surface winds creating a lot of directional shear between 0 and 1 kilometer, and with those further right storm motions pretty close to due easterly at about 40 knots, you definitely squeeze out quite a bit of storm relative felicity, near 200 0 to 1 kilometer storm relative felicity up there across central lower Michigan, Houghton Lake, Mount Pleasant area, back toward the Thumb, Saginaw. You might even be able to get a Wolverine with a tornado in the background there. I know there's been some Wolverine sightings around the Bad Axe area out there, Thumb of Michigan. I actually grew up in Grand Rapids out there. I've never seen a tornado in Michigan, in my home state, believe it or not. So it is a difficult place to chase. Sometimes Lake Michigan can act to reduce that tornado threat. They can kind of lose their surface-based supercell structures. And you can see here that the 0 to 1 kilometer EHIs are a little bit enhanced right along that warm frontal zone into the early afternoon hours. Some of these supercell storms that just came ashore from Lake Michigan could easily latch into that surface-based instability. Those leading supercells, those initial ones that move across the warm frontal zone, those are the ones that are going to have the greatest tornado threat. And anywhere back behind and southwest of that, of those initial supercells, more of a linear mode with those 850 winds veering with time. Even though they are intensifying in magnitude, they are veering, especially those surface winds, creating relatively unidirectional surface winds down there. We can see that right now looking at the photographs down in Grand Rapids a little bit south of that. Well, those are actually pretty favorable photographs. 84 over 64 to 20-degree dew point spreads. South-southwesterly surface winds. A lot of speed shear in there, going from 15 knots to 45 knots just above the ground. So even down toward Grand Rapids early on in the period, pretty decent photographs throughout lower Michigan and the Thumb. But let's see how this evolves with time. Moving toward 21Z. Notice how we lose those yellows, those strong 0 to 1 kilometer EHIs out there across southern lower Michigan, and slightly more favorable kinematics will eject across southern Lake Huron and across southern Ontario. So if you can get some supercell storms that are able to maintain their characteristics across Lake Huron, then there is definitely a chance of even a strong tornado. Look at those due southerly surface winds, more of a backed low-level jet, still 77 over 68, deeper moisture than probably is being indicated than on the surface maps. But those veered low-level winds below a kilometer are enough to even generate a PDS sounding there across southern Ontario. So I do think that Thumb area across central southern Lake Huron out toward southern Ontario looks like the most favorable area for tornadoes. And then a squall line building down through central and southern lower Michigan, through the Grand Rapids area, into Chicago. Seems likely as those surface winds veer behind those initial supercell storms. And they don't veer that much, though, so but they are more backed over southern Ontario, Lake Huron zone out here, more due southerly surface winds, creating a lot more wind shear, and then those surface winds back to a southwesterly direction across central, southwestern lower Michigan, decreasing that tornado threat just a bit. And let's say, for fun, even though the HRRR doesn't really initialize the dew points properly, it does seem to handle the low-level kinematics well with the ejection of those more backed low-level winds. A little bit of a subtle surface pressure perturbation here, and there could be some lead supercells that are able to march across that warm frontal zone, across northern lower Michigan, through the thumb area, across central southern Lake Huron, and then eventually into southern Ontario, bringing with it that tornado threat. And looking at the convective mode here, being predicted by the HRRR. Interestingly, the HRRR does have more of a kind of a broken supercellular mode across that squall line. And boy, given the bulk shear, the favorable bulk shear, especially across lower Michigan, I wouldn't be surprised to even see a few tornado warnings embedded within that line and not quite that massive linear windbag that the 3-kilometer NAM is showing. But it is definitely showing these lead supercell storms moving across central Lake Huron, southern Lake Huron, into southern Ontario, moving into the more favorable environment for tornadoes there over land. Possibly could see some more landfalling water spouts moving across Lake Ontario, northeastern lower Michigan into the thumb area. By 20Z, looks like there could be a tornado threat. Oftentimes, the HRRR is right for the wrong reasons, even though it does have a very dry bias out here. It'll still get the convective evolution and storm mode relatively accurate. And it does have these supercellular modes here along the warm front, eventually passing over central southern Lake Huron and then over to southern Ontario. Decent low-level jet feeding into these things. Kind of the nose of that low-level jet as well, there by 18Z. So let's shimmy back on over to the radar and see if some of those supercellular structures that are currently elevated are becoming a bit more surface-based. We got a tornado warning. So it's already happening now. We do have a tornado warning for this storm here, Highland area, Marion. So it does appear that that surface-based instability is meeting up with the appendage of one of these lead supercell storms. So this is going to be your event, storm chasers. I do think that any of these elevated supercell storms that are coming in off Lake Michigan right now, back toward M37, these are likely going to remain elevated. And it's this storm here that is going to be able to latch on to that warm front and move all the way across central, northern Lake Michigan, or lower Michigan, and then eventually toward the thumb area as well. So Marion to Harrison, Michigan, you do have that tornado warning already in place as it is starting to latch on to that surface-based instability. You're seeing it play out here in real time during this outbreak. I'm not seeing too much in the way of incredible rotation out there. Maybe near the Marion area. Gaylord is off to the northwest, so that could be a little easterly inflow pop. Let's loop this radar. Does look like there could be a bit of a tornado there, a little bit of an RFD surge near the Marion area. That's where that tornado would be. Right along the leading edge of that appendage. So Pisgah Heights right now, Park Lake, Marion, you're included in that tornado warning right now. It's radar indicated. I'm not seeing anything that is screaming tornado on the ground right now. Just looks like a bit of a RFD surge, and likely what will happen with this relatively long appendage here on the back side is eventually that potential vorticity kind of along this leading edge here will consolidate. You'll see a hook-like appendage, a cyclonic hook wrap around out of that appendage there with coincident with that RFD surge, and then it'll develop into a more robust tornado threat. Let me shift to a little bit brighter color here. So right now, Marion, you want to be in your safe place. Marion, Michigan. Park Lake, you're probably getting big northerlies right now within that hook echo. A lot of northerly winds, strong northerlies there, driving rain within this elongated hook-like appendage, and we are waiting for an inflow notch and for the southern edge of that hook-like appendage to develop some cyclonic curvature. It does look like we're starting to get just a little bit of a weak echo region in there into the Marion region associated with that inflow. So it is very possible that the southern edge of that hook-like appendage could wrap all the way around that weak echo region, and we could be talking about a tornado potential. So this is the supercell storm. This is the event. The robustness of the tornado potential also depends on if this leading storm up here is able to kick out a big-time outflow boundary. It's possible that this storm could latch on to that outflow from this lead storm that just went through the Houghton Lake area. If it can latch on to that outflow boundary, there could be a mesoscale accident type of a tornado that is trying to happen. But you've got this elongated hook-like appendage as this storm is trying to drill southward, reach down to that surface-based instability that is lifting off to the north. The warm frontal zone is right about like that. So you got a lot of surface-based instability building to the south of that warm front. Off to the north, though, this storm right now is probably elevated above just a very shallow stable layer, but it's in the process of drilling down. And when these storms have a mesocyclone, it makes them much more effective at drilling through that shallow stable layer and producing a tornado, and that could be happening down there near the Marion area. We just looked at the SPC meso analysis, and we do have about 1,500 to 2,000 capes streaming up into this environment. We got about 150 to 200, 0 to 1 kilometer storm relative helicity, certainly sufficient, more than sufficient to develop a tornado threat. So right now, Marion area, Marion, Michigan, you want to be in your safe place. Tornado warned storm here, closing in on town in Marion. Definitely want to be in your safe place. And this is just the beginning of this event, but I do think that the tornado threat is going to maximize during the early to middle portion of the afternoon with these lead supercells as they trek across northern lower Michigan, eventually arriving toward the Thumb area as well, where there's a prime environment for tornadoes. I'm wondering if this storm here, that severe warning just to the southwest of Baldwin, could also try to become surface-based and might even be more effective at latching on to that surface-based instability there. Just to the Lilly area. This one to the east of Marion does look just a little bit elevated to me, and I think that it's because of that lead storm that just went through Houghton Lake. It's kicking out an outflow boundary and a little bit of stable air. You can kind of see the shape of that system there. Definitely more of a windbag, but that system is trying, this supercell is definitely trying to latch on to that outflow boundary. Could cause more of a mesoscale accident type of a situation, but I'm definitely more concerned about this storm back here southwest of Baldwin. I think that it has a more mature, elevated mesocyclone, and there you can see that elevated mesocyclone there just to the southwest of Baldwin, near that the Huron Manistee National Forest as well. I think that this mesocyclone will have even a better chance at becoming surface-based and drilling down to that shallow stable layer. It's a little bit further south, has more of a chance of developing that deviant motion, and then I think that it'll cut right into that more southerly low-level jet. But these two storms are definitely the event out here. And this southern storm looks like it's also getting more of a mesocyclone as well. But this, I think, is the most dangerous storm. This one just to the southwest of Baldwin. I think that it's more of a supercell structure. It definitely has more deviant motion, too. Almost moving due east there. So I do think that that storm has the best chance of becoming surface-based as we go through the afternoon. And one of these two supercells is going to dominate as it moves across northern lower Michigan, eventually across central southern Lake Huron, and then over toward southern Ontario as well. But I do think that this tornado warning, more of an environment-based tornado warning. They're aware of that warm front that's lifting from south to north through southern lower Michigan. The National Weather Service meteorologists, I'm sure, are aware that that storm is trying to latch onto an outflow boundary, but is struggling to latch onto that. It likely is elevated above the stable air caused by this lead squall line right here. This lead squall line, a lot of rain-cooled air, big-time windbag there. It's kicking out stable air. That's likely going to choke off this supercell back behind it. Damaging winds, though, definitely possible down toward Marion. Another storm that was trying to get going back further southwest is likely going to struggle with that outflow boundary as well. And that outflow boundary could continue to sag south and then reinforce that warm frontal zone out ahead of this dominant supercell. So Reed City, Everett, down toward the Clare area. Keep an eye on this supercell storm. Right now it's elevated, but it is in the process of trying to become surface-based. Definitely has very substantial deviant motion as well. And I do think that that outflow boundary from that lead storm that just went through Houghton Lake could reinforce that warm frontal zone. And this storm, this elevated supercell southwest of Baldwin, certainly could latch onto that warm frontal zone. Squeeze out quite a bit of wind shear. The low-level jet and the surface winds especially are going to remain relatively back ahead of this storm, and then back to the southwest of that storm, more of a windbag event that's going to settle in toward the Grand Rapids area. Still some severe thunderstorm warnings back toward Milwaukee as well. More veered winds back here. Look at more of the linear convective mode along that frontal zone through Beloit up toward Milwaukee. Severe thunderstorm warning in Milwaukee. And it's possible that some of these storms that are over Lake Michigan also could mature into surface-based supercell storms interacting with the warm front. But if this storm to the southwest of Baldwin is able to dominate, it's going to send out and reinforce outflow as well. And it might make it more difficult for these storms to latch onto that warm frontal zone. Or each one will just keep coming in a little bit further south with greater likelihood of becoming surface-based and tapping into that 40 to 50 knot southwesterly low-level jet. Eventually, then there's going to be more of a squall line back behind it. But these are the storms that we are monitoring. Tornado warning, southeast of Cadillac. I don't think that it has a tornado on the ground. Definitely seems more elevated. You've also got this supercell structure moving out over central Lake Huron. Keep an eye on this. Port Elgin, Kincardine, Goderich areas. Keep an eye on this lead supercell storm that is moving over central Lake Ontario. This thing's likely going to move more of a due easterly direction, but I wouldn't be surprised if we see more landfalling supercell waterspouts, Port Elgin down toward Kincardine area, maybe as far south as Goderich later on today, but the lakes are relatively warm after a full summer of heating up, and that lead storm there definitely has me concerned, especially any boats there over central Lake Huron. It's possible that this thing, it is well northeast of that surface-based instability, but it does have a mesocyclone and maybe even a spout, maybe a water spout well north of Port Austin. Right there's the tip of the thumb, pretty near the mouth of the Saginaw Bay there in Lake Huron, southeast of Sable Point. Possible water spout in progress. So let's take a look at some of that surface-based instability and how it's going to evolve today out ahead of that storm. So it does look like that storm over central Lake Huron is a little bit north of the warm frontal zone that, according to the 17Z RAP analysis, slides southeast to the central portion of the thumb toward the southern tip of Lake Huron. But I imagine that is lifting off to the north. You've even got some backed winds there right off the tip of Lake Huron. A little bit of stable air there as well. But let's see in a couple hours as the supercell storm is going to be about to make landfall across Port Elgin. Notice how that in about 4 hours, 21Z, 4 to 5 p.m. out there, that warm frontal zone finally lifts up and meets that dominant supercell storm. Right now it's near the mouth of Saginaw Bay, north of Port Austin, but eventually it's going to be moving into surface-based instability there that develops across southern Ontario. Notice how that surface-based instability evolves. Warm front lifts off to the north. Surface winds remain backed across southern Ontario. So this is definitely another tornado event, a pretty substantial tornado event. Oh, let me center this model imagery here so that you can see that warm front lifting off to the north. There we go. So this is at 17Z, the initialization, 2 hours. So you can see that warm frontal zone lifts northward into central Lake Huron. You can ignore that convective inhibition right over the lake surface and really focus on the Ontario side. See that surface-based instability surge northward through Goderich up toward Port Elgin just in time to meet that supercell storm when it makes landfall there in southern Ontario. So I do think that there is a decent chance of a pretty substantial water spout coming ashore out there near the Goderich area. Special marine warning out there as well over the open waters of Lake Huron. Let's see what this thing says. Moving east at 30 knots. They don't mention waterspout, small craft, briefly higher winds, large hail could result in structural damage. But I do think that it does have waterspout potential. Definitely are some mesocyclones there. It is off of All Sable Point. Couple little mesocyclones, that lead one, and then one back behind it, trying to back build there as well. But we do have this active tornado warning further west. I do think it's going to be allowed to expire. I don't think that has very much tornado potential, that storm that just moved through the Marion area. I do think that it could produce maybe some damaging straight line winds there to the northeast of Marion. Decent hail core as well. South of Vogel Center. That's where that largest hail is located. But I don't see any immediate big-time tornado threat. That's just a bunch of turbulence noise down there. Some damaging straight line winds back toward Pisgah Heights. So that warning will probably be allowed to expire. And I do think that this storm to the south of Baldwin, a full-blown supercell storm, looks like it is pulling in some inflow as well. I like this cyclonically curved inflow zone. Big hail core just to the southeast of Idlewild, there south of Nirvana. But I think that this storm has the greatest tornado threat, as it is going to be able to more easily latch on to that warm frontal zone. And I think that outflow from some of these lead storms here is going to help to reinforce that warm frontal zone across this area. So basically, north of Big Rapids, out toward Clare, maybe Mount Pleasant. That storm might pass just a little bit north of Mount Pleasant. But that line, I think that there is a decent tornado potential with that storm. And we also are monitoring that one over central Lake Huron as well. So I wouldn't be surprised if Storm Prediction Center does decide to upgrade those tornado probabilities to a 5%. But definitely big wind event with these supercell storms maturing along this convective line. And those supercell storms that are able to develop stronger mesocyclones will have more deviant storm motions and will have a greater likelihood of moving into that surface-based instability. So I'm going to continue going live during this severe weather event. Hope you enjoyed my new setup here. I've got my mic set up. I've got the new armored Dell laptop. Better video card dominating here. Still need to get used to some of the graphics as well. So thank you everybody for tuning in to my weather reports. There's the target area. Ahead of that, intensifying trough, intensifying low-level jet. And I do think that the greatest tornado potential is along that line, basically through Clare up towards Saginaw Bay, right along that reinforced warm frontal zone. So thank you everybody for tuning in to my weather reports. I'll be going live throughout the rest of the day as this severe weather threat continues to evolve. Never stop chasing.